All right, so we're going to go through some strategies for evaluating limits. One of those is graphically, which you did in your 10-1 stuff. But the first strategy you guys should always try is just direct substitution. So what I mean by that, let's say I ask you limit, and I won't say it about the limit of let's say I gave you that. Limit of x squared plus 1 as x approaches 2. Right now you guys go, okay, I'm going to graph that, and then I'm going to look around 2 and see what's happening. You don't have to make the graph of this. If you can just plug in the 2, that will give you the limit. Okay? So if I plug a 2 in, what do I get? 5. That's it. Okay? You can't do direct substitution if, let's say, it was as x approaches 2 of x over x minus 2. Could I plug it into that? No, why? What would happen? Yeah, you'd be dividing by 0, so that is not one that you can do with direct substitution. For that, you can try one of the other strategies. That example in particular, you would need to think about the graph, like there'd be an asymptote at 2. What does the graph look like? Okay. Your second strategy, you can find a g of x that is the same as f of x for all values except x equals c. That's a very wordy way to imply you're going to remove the whole. And I'll show you. Let's do the limit as x approaches to x squared minus 4 over x minus 2. We can't just directly substitute it in, right? You divide by 0, or you get 0 over 0, which is still not okay. So what we can do is factor. So this is still the limit as x approaches 2. And then that'd be x plus 2 times x minus 2 over x minus 2. So you guys see how you can cancel out that factor? Remember, that's a hole in your graph. Yes, okay. So we can get rid of that guy. Now you can do your direct substitution, and what would our limit be? 4, yes. You okay with that? Pretty easy so far? All right, your third strategy is just what we did on 10-1, is just make a graph. A lot of the ones you had in your homework 10-1, you were graphing with your calculator. most of the time, if I'm making you graph it, you have a calculator, but there's a few that I would expect you to be able to do without a calculator. Like, let's say I gave you something like that. We can't just plug the 0 in, right? And there's no nice factors to cancel it out. So 2 ways you can think about it. You can think about what happens on either side of the graph, but definitely think about making the graph. So what does this graph look like? Like, what's happening?
Inverse.
Inverse, okay. Do I have like some asymptotes on this graph?
Yeah, it's 0.
Yeah. Got an asymptote there, and then I've got one there too, right? It's one of those parent graphs you're supposed to remember.
Yeah.
Okay. You can't plug in 0, so there's no y-intercept, and there's no way that numerator is ever going to equal 0. The screen's kind of weird today, right? It's really shaky. Stop being creative. All right, so you should recognize that the graph. Does this have to be like a perfect graph with points plotted? No, I'm looking for general shape of the graph. That's one you guys should definitely know. So what would you tell me about the limit as x approaches 0? Does not exist, right? Going in opposite directions, you can just tell me does not exist. Okay. We all right with that one? So those are the types of graphs, ones with asymptotes, that I would still expect you to have an idea, like your rational functions. Again, not perfect graphs, just general ideas of the shape so you can figure out what the limit's doing. Okay? All right, then your last strategy is to just look from the left and look from the right. So find the limit of f of x as x approaches c from the left, and find the limit as x approaches c from the right. So you could do that graphically, or you could substitute in values. Values that are very close to c. So like if I'm asking you the limit as x approaches 2, you could plug in like 2.1, 2.01, 1.9, 1.99, like values that are getting really close on either side. That's the strategy you'll use the least. Okay. All right, so a couple of other examples here. Let's say I've got the limit as x approaches 3 of the square root of x plus 1 minus 2 over x minus 3. All right, can I just plug in the 3? Nope. That's always the first thing you should think about trying, though. Just check, like, can I plug that in? If not, then you got to do something else. It doesn't look like any nice factors here that I can cancel out either, right? Okay, so we are going to use the conjugate, like when you guys rationalize, do you remember that, the conjugate? I know the square root is not in our denominator this time, but we are going to go ahead and multiply by the conjugate anyway. So I'm going to have x plus 1, sorry, the square root of x plus 1 plus 2. That's what I'm multiplying both numerator and denominator by. Make this the limit of all of them. I haven't changed the value, right? That's just a well-chosen one. Okay, don't go crazy with your multiplying yet. Limit as x approaches 3. Let's go ahead and multiply the numerator. So what's square root of x plus 1 times square root of x plus 1? Okay. And then do you guys see how it's going to be a positive 2 square root of x plus 1 and a negative 2 square root of x plus 1? Okay, so then we would just have minus 4. Okay. Over, do not multiply out your denominators here. Leave it as x minus 3 times the square root of x plus 1 plus 2. Because what does my numerator really become? I'm just going to erase it and write x minus 3. You guys okay with that? And then what can I do? Yes, now we have a hole we can get rid of. So there's a 1 up there. Can I substitute now? Yes. What do I get? 1/4. Right?
Oh,
Yeah, okay. If you had actually multiplied out your denominator, you'd have a big mess and you wouldn't really know where to go because you still couldn't plug it in. So just be careful when you're rationalizing. Multiply the two that are conjugates of each other and leave the others factor. Okay? It'll keep it easier. Alright, let's do one more on here before we go back to your package.
So,
Yeah.
so like, why couldn't you just plug in, like at the beginning?
Plug in the 3. So what would happen right here?
Oh, 0.
Yeah, so that's why. But definitely always check that first. Sometimes it'll look like a really complicated problem, but all you have to do is plug it in. Okay. All right. One more example. The limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3. You guys try this one. All right, guys, do you have an answer? I guess that's attendance. -5, yes. How many got -5? Yes? Anybody's troubles with this one? Okay. Do we like this so far? Yes, sir. Go through it, sure. All right, so... Did you guys notice how I'm writing this limit thing in every step when I'm showing my work? You should be doing that, okay? Get in the habit of that. It's going to matter in calculus. All right, so I would factor that numerator first. Okay. So then I can cancel those out and then just directly plug in that -3, okay? All right. Good so far? Okay, so guys, find the page in your packet that says 10 to continue, techniques for evaluating limits. Looks like this page. Okay, guys, so there's a lot of words on this page, I know. I'm sorry. The first thing that really matters are these two special trig limits, okay? You cannot evaluate these by just substituting in. You would have to look at the graph. We're not going to graph them right now, though. I'm just going to tell you what they are. So the limit as x approaches 0 of sine of x over x, that always equals 1. You must know that, okay? And then the second one, the limit as x approaches 0 of 1 minus cosine of x over x, that will always equal 0. So these two, very important. These could show up on a trig quiz, okay? You do. It's a trig quiz. Don't miss those classes. All right, so commit those to memory. You got to know them. You'll use them when you're simplifying other limits, okay? All right, let's practice a few. So number 1. That looks terrible to factor, right? Do we even need to factor it though? No, what can we do to find the limit? Plug it in. So guys, take a second to plug it in. Without a calculator, do the multiplying, adding, and subtracting. I know. You can do it. I know you can. How we doing, guys? Can we multiply, add, and subtract, or is that tricky? Back to the good old days. Anybody think they have it? All right, Jonathan.
215.
Okay, I like that. Does that reduce? So you got 213 over 51. What is 2 plus 1 plus 3?
6.
Okay, what is 5 plus 1?
6.
Both of those are divisible by 3, right? Yep. 71, yep. So the final answer is 71 over 17. Anybody need help with the multiplying? Anybody like just way off? They're like, I don't know what happened. Okay. All right, so first up, always just try to plug it in. Try number 2 for me. You guys, those of you who were gone, I can tell your test scores. So you don't know that yet, right? Is there anybody else who didn't know? Okay. All right, guys, what'd you get for number 2? 5, yes. Anybody need me to go through it? Okay. 3 and 4. 3, do you remember how to factor into 3? Oh, no, just 2.
No.
I thought you were just asking.
Oh my god. Try this one too again. Try 4. So conjugate 1. All right, guys, what'd you get for 3? 3. Okay, yes. Anybody struggling on 3? Anybody need me to go through the factoring? Are you sure? Okay.
Let's see how you did with the conjugate. What'd you guys get for number 4? 4. Okay. The answer to number 5 is not 5. Okay. Try 5 and 6 for me. Okay, sure. So, this is one where you want to multiply by the conjugate of that denominator. So square root of x plus 2. Okay. I'm not going to multiply out the numerator. Okay, I'm going to leave that factored. So x minus 4 times square root of x plus 2. But I will multiply out the denominator. What does that become? Do you see it there?
Yeah.
Okay. All right, so then these cancel, and now I can do my direct substitution. So when I plug the 4 in, that's 2, 2 plus 2, 4. Okay? All right, guys, 5 and 6. So 5 is, yet again, the conjugate one. 6, you got to think a little bit. Like, let's say I had the fraction 2 over 4. That reduces to that, right? It doesn't reduce to that. So like if the x cancels out, there's still a 1. Right, you had x plus 1 minus 1, which is just x over x times whatever. So when those cancel, x divided by, yeah, okay. Yeah, 2, 6. 6 is the trickiest one on here. Definitely gonna have to use one of those things in that box with all the stars.
But how? Yeah, I know. So, but you need
Okay, like, that's it.
Really? Are you serious? this one. I'm good.
Stuck on 6? Yeah, a little bit. Alright, let's go through 5 together real quick. So are we multiplying by square root of x plus 1 plus 1? So when I multiply, what am I left with in my numerator? X, and then eventually 1, yes. So I can cross those out, which leaves a 1. And then when I plug the 0 in, 1/2 is my answer at the end. Are we okay with that? So the conjugate ones aren't that bad, right? Okay, yes.
Sorry.
No, it's fine.
So for the conjugate ones, for the safest, do you that we're always going to be like canceling out the other term and we're only going to be left with
It should work
conjugate?
that way, yes. Yeah. Alright guys, did you get stumped on 6?
Yes.
A little bit, yeah. Okay, so you guys know tangent is sine over cosine, right? And then I can say times 1 over x. Do you guys agree that that is the same as tangent of x over x? We're okay with that? Okay, so just to write it another way, tangent is sine over cosine. Yeah, do we see it now? Okay. So, is that the same? Yeah. Okay. So this is actually one of our properties. Walking around, I saw a lot of you were like, oh, sine of x over x, that's 1, and just got rid of it. Sine of x over x is not 1. The limit of sine of x over x as x approaches 0 is 1, but not the fraction itself. Okay? So what we can do, you can actually write this as 2 limits. Times the limit as x approaches 0 of 1 over cosine of x. Then you can evaluate it. So the limit as x approaches 0 of sine of x over x, that whole thing is 1, times, can I just plug 0 into the other one? Yeah, because what's the cosine of 0? 1. So this is really 1 times 1, which is 1. Those of you that just crossed out sine of x over x, you still got 1 at the end, but just be careful. It's not always going to work out that nicely, so definitely show this notation. Okay?
I don't understand why sine, what is 0 sine of x over x, which is 0 over 0.
Yes, 0 over 0. Oh, no. Okay? Don't ever do 0 over 0. It's not good. You cannot have 0 over 0. You cannot have infinity over infinity for your substitution. It doesn't work. Okay, 0 over 0 is still you dividing by 0.
Yeah, exactly.
Yeah.
Then why is the limit of sine of x over x?
So it doesn't exist at 0, right? The function value doesn't exist there, but the graph, the limit as it approaches 0 is still 1. If you were to graph on your calculator, just go ahead and graph sine of x over x and look at it as you get close to 0. So make your window fairly small. Radians.
Oh my god.
1.
I was sorry.
Okay, guys, let's turn the page. Or maybe it's the other side of your page. I don't know. Okay, so what did I do?
Yeah.
Maybe. There we go. Okay. So if you plug a 0 in to that, that's not a 0, that's a 7. What is the cosine of 0? And 1 divided by 1. So if you break it into pieces, you can use like substitution in one part, something in another part, like that's fine.
What's the sign x for x?
That's one of, yeah, that's one of the two that you got in there.
Yeah.
No, that's okay. You don't know it yet. I know that, so gotta keep practicing it. All right, let's look at the next page here. So we're now going to find the limit of f of x as x approaches 3, and I give you this piecewise function. So what do you think, guys? How should we start this one? Plug in 3. Do I need to graph it? No, just plug in 3 to both of them. So when I plug in 3 to the first equation, what do I get? 9. When I plug in 3 to the other one, what do I get? What'd you say, sorry? 14, good. Are 9 and 14 the same thing? No, so does not exist. You guys got that over there? Oh, yeah. You sure? Alright.
Oh, for the second equation, 6x minus 4, doesn't it say that x is less than 3?
Right, so you would have like an open circle on your graph, but you could figure out the y value of that open circle. Okay. Alright, we okay with 7? Alright, so number 8, find the limit of f plus g of x when x approaches 2. So this is one of your properties. What you need to do is find the limit of f of x as x approaches 2 plus the limit of g of x as x approaches 2. So you've got two graphs here. You have your f of x graph and your g of x graph. So what is the limit of f of x as x approaches 2? First, do we care about that dot up there? No, that has no impact on the limit whatsoever. So what is the limit as x approaches 2? 1 plus, yeah, looks like 3. So your answer is 4. Okay. Does that seem much simpler than what it looked like? No. Yeah, definitely. Okay. All right. You guys try number 9. It's another piecewise one. Talk to each other. Do you agree? Everybody agree that it does exist? And what is it? Yeah. But this one, when you plug in your 4, you get a 0. You plug in your 4, you get a 0. So yes, limit of f of x as x approaches 4 is 0. Okay? All right, let's do number 10 together. And if you're wondering what those crazy numbers are out in front, this is like the AB stands for AB Calc 1993. That's the year of the test. So these are multiple choice questions from an AP Calc test. Okay. All right, so number 10, f of x equals 2x squared plus 1, and we want to find the limit of f of x minus f of 0 over x squared as x approaches 0. So first, let's figure out what this is. Like, let's substitute in there. So I'm going to have the limit as x approaches 0. Well, what is f of x? Okay, so 2x squared plus 1 minus f of 0. Well, what's f of 0? 1, okay, over x squared. So f of x is 2x squared plus 1, right? So write that. Then it says minus f of 0. If I plug a 0 in here, what do I get? So that's why it's minus. Alright, so if we go to simplify this, I've got the limit, x approaches 0. What's left in my numerator? 2x squared over x squared. So 2. And this was one of your properties, guys. If it's just a constant like that, it's just whatever the constant is. Because if you graphed that, that's the line y equals 2. Think about it. No matter what my x is approaching, what is my y value the whole time? 2. Okay, so the limit of this is 2. What? So, yeah, like if I ask you the limit as x approaches 7 of 3. It's 3. Think about it. 1, 2, 3. There's your line. Okay, yes. This could be as x approaches, you know, negative 85. It's still 3. Okay, yes. It is that simple. That's okay. We are skipping 11, so let's go to 12. Okay, so the limit as x approaches 2. Let's look at this. Now, you would not have a calculator for this. We would plug it into our piecewise, right? So when I plug it into the first one, I get natural log of 2. Okay, you don't really know what the natural log of 2 is exactly, but that's okay. If I plug 2 into the second one, I get 2 squared, which is 4 times the natural log of 2. Do you think the natural log of 2 and 4 times the natural log of 2 are the same thing? They are not. They're not the same thing. So what does that mean about our limit there? Yeah, it doesn't exist. Okay, so even though you don't know what that value is, you know those are different values, which is what matters.
Did we skip over
We did, yeah. Half of it. Half is non-calculator, half is calculator. That's why you have to get used to no calculator this year. Otherwise, it's a rude awakening in calculator. Okay, you guys try 13. I know there are a lot of letters. We skipped a letter. Way to pay attention over
Is it B?
there. You're just randomly guessing.
Yeah.
Try it and see. Try some factoring.
Oh,
No, for
yes.
B, or for 11.
Oh, for 11? No, it's actually B. How are we doing, guys? Close? Okay. Give me a minute.
Because this keeps
If you factor the top, you just have to do extra factoring on the bottom. You can still get there, it just takes longer. All right, let's look at it, guys. So the limit as x approaches a, I'm going to go ahead and factor just my denominator to start with. Right, difference of squares there, factoring your denominator. And then you can cancel out your numerator with half of your denominator. So you have 1 over that. Then it's just direct substitution, so you have 1 over a squared plus a squared, which is 1 over 2a squared. So B was your answer. Where'd I leave your name? How what? So, were you okay with this?
Yeah, I got
that.
to 1 over. I got to 1 over x squared plus x squared.
Okay, then you can just do substitution. X is approaching a, so plug an a in. No, imagine. You asked. I know, that's what I was like. That's so sad.
Oh my god.
All right, guys. Just 2 more that I want to add to this. You still have to think about limits as x approaches infinity. Last class at the end, remember we talked about how if it's approaching infinity, it does not exist. That is only if you're finding the limit like at a defined value. So like if x is approaching 4 and your graph has asymptotes, that cannot be infinity as an answer. If I'm asking you the limit as x approaches infinity, you can get infinity or negative infinity as an answer. So let's think about this one. Let's say limit as x approaches infinity of x cubed. What do you think? Infinity. Okay, that's okay. That's not, does not exist infinity, that's just infinity. Do you guys, do you see what I'm saying, the difference between the two? So if it had been like the limit as x approaches 4 of your function and your graph at 4 had an asymptote and like looked like this, that would be infinity does not exist, because this was a specific value, right? Which means you need to get a defined value as your answer. If this is infinity, you can have infinity as an answer. Okay, does that help? Okay, and let's do just one other infinity one just to make sure you guys remember. Let's do the limit as x approaches infinity of 2x squared minus 5 over x squared plus 2. Okay, it's hard to just plug infinity in, right? So remember, your horizontal asymptotes of your graphs tell you about the end behavior. So what is your horizontal asymptote in this case? 2. That means as x approaches infinity, your graph is going to 2. Okay, so just that's how the rational functions and the limits go together. So you look top heavy, bottom heavy are equal. They're equal, right? So then you just divide leading coefficients, and that's because if you were graphing this, you'd be like, okay, I know I have a horizontal asymptote here. What that means is your graph is approaching that asymptote as you go to infinity. The horizontal asymptote. If you're looking at infinity, yeah. Okay? All right. In your packet, you have 2 puzzles. You have the lovely Buzz Lightyear, and it's to infinity and beyond. And then on the back of that, you have a nice riddle. What did one math book say to the other? I want you to do both of those, and then Let's look at your bookwork. We may just do just the worksheets for homework, okay? So go ahead and start on the two puzzles.